Welcome. So today we're talking about the semantic web. Now that sounds super technical, right? Something for coders and computer scientists. But what if I told you the secret to building it isn't really about writing code, but about cataloging? Yeah, let's get into why the entire future of the web might just depend on the skills of a librarian.
So let's start with a really basic question. Just think about the last time you searched for something online. You type in a few words and bam, you get millions of results. It's amazing, but it's also, let's be honest, a little bit clueless. The search engine doesn't understand what you're asking. It's just matching strings of text. It has no idea about context or meaning. And that problem, well, that's a problem librarians have been solving for centuries, just on a slightly smaller scale.
And this chart right here really gets to the heart of it. The web we have today is all about statistical keyword matching. It's a numbers game. The semantic web, the vision for the future, is about something totally different. Logical understanding. You know, it's the difference between getting a giant list of links you have to sift through versus getting a direct, smart answer. It's like the difference between a keyword index and a conversation with a really good reference librarian.
So how in the world do we get there? Well, the whole idea actually came from the guy who invented the web in the first place, Tim Berners-Lee. He realized that for the web to truly evolve, it had to stop being just a collection of documents linked together. It needed to become a web of data.
And this quote from him says it all. The key phrase, the absolute core of the idea, is well-defined meaning. It's all about giving the information that's already out there a structure that machines can actually comprehend, not just display on a screen. And the goal isn't to replace us. It's to create a web where computers and people can finally, truly work together.
All right, so to pull this off, you need a common language, right? A universal set of rules. You can really just think of it as a grammar for this new web of data, a way to teach machines how to read and understand.
And the foundation of that grammar is something called the Resource Description Framework, or RDF. Now, don't let the name throw you off. At its heart, RDF is just a really simple, standard way to make statements about, well, anything, any resource. It's the basic building block for adding that layer of meaning we've been talking about.
And the way RDF does this is just beautiful in its simplicity. It uses something called a triple. And a triple is basically just a simple sentence. You've got a subject, a predicate, and an object. So for example, we could say, Marcel Proust, that's our subject, is the author of, that's the predicate, the relationship, In Search of Lost Time. And that's the object, see? Just a clear, logical statement.
Okay, but here's the real magic that makes this whole thing work for computers. Every single part of that sentence, the subject, the predicate, and the object, gets a unique global ID called a URI, a Uniform Resource Identifier. Now, for everyone listening, the absolute best way to think about a URI is as a universal call number. It's a specific, one-of-a-kind address for any person, place, or concept in the entire world. No more ambiguity.
So, our simple sentence about Proust gets transformed into this. It's now a machine-readable statement. Each piece is a unique web address, so computer doesn't just see the word creator, it knows we mean the specific definition of creator from the Dublin Core vocabulary. And it knows exactly which Marcel Proust and which book we're talking about. This is how the web starts to get woven together with meaning.
Now, if all this talk about creating structured descriptions, defining relationships, and using controlled vocabularies is starting to sound familiar, well, you're absolutely right. This is where your expertise isn't just helpful, it's the key to the whole thing.
I love this quote from the library science world. Classification by any other name is still a classification. It's so true. For years, computer scientists have, in a lot of ways, been independently reinventing the exact principles of knowledge organization that librarians have been perfecting for over a century.
And this slide right here is basically the decoder ring. It just lays it all out. When a computer scientist talks about building an ontology, what they're really doing is creating a classification scheme, or a thesaurus. A taxonomy, that's a hierarchy. A knowledge base, that's basically an authority file or a catalog. It's the same work, just with a different set of buzzwords.
So let's see what this looks like when we move from theory into the real world. Because these ideas are already transforming the classic library catalog from a siloed little database into a connected node and a massive global knowledge graph.
And the way this happens is through something called linked data. It's really just the practical how-to for using RDF. The whole point is to publish data in a standard way so it can all connect, allowing machines and us to follow the threads and discover relationships between things, not just jump between web pages.
And Tim Berners-Lee gave us 4 beautifully simple rules for this. 1.
Use URIs for everything. 2. Make those URIs work like web links. 3. When someone clicks that link, give them useful, structured data. And 4, the most important one, include links to other URIs. That's how the web of data grows.
And hey, this isn't just some academic pipe dream. Look at the National Library of France. Their data.bnf.fr project is a perfect example. They took all their different catalogs and turned them into linked data. So now, their record for an author doesn't just live on its own island. It links out to authority files, to Wikipedia, to all sorts of other datasets, creating this incredibly rich web of context.
So, this all brings us right back to you. The technology gives us the scaffolding, but it's an empty shell without the expertise to fill it with well-organized, meaningful information. To build this next-generation web, we don't just need coders, we need knowledge architects.
So what does this actually mean for your career? Well, your skills are in huge demand. We need people who can translate specialized vocabularies into these new formats, who can enrich our thesauri with deeper semantic connections, and who can design entirely new ways of seeing and organizing information. It's not about getting rid of catalogers, it's about the evolution of the cataloger into an ontologist, an architect for the digital world.
Hey, if you're finding this explainer useful and you want to see more stuff like this that connects the dots between library science and technology, do me a favor and hit the like, share, and subscribe buttons. It genuinely helps us keep making these explainers for you.
So let's end on this thought. The web right now is like the biggest library in human history, but it's a library with no librarian. There's no catalog, no system, no real organization. It is a beautiful, chaotic mess that is desperate for some structure and meaning. So my question is, who better to build that future than you? The very people whose entire profession is dedicated to doing exactly that. Thanks for tuning in.